Okay. Oh, darkroom. This is really loud. Okay, find a free seat so we can start. Okay. Who's coding Java on a regular basis? Okay, good. You know that this is about old plain Java. Yes? Okay. So last one coming in. Here 2 free seats if you want. First line. Okay. So let's start. I want to talk about proxies today. This is something, I think the most of you heard about it. But first I introduce myself. I'm Sven from Germany and I'm working for Vardin. So I started with Java since 1996. So if you have some questions about how it's done in .NET or whatever, I have no clue. But mostly I was working in distributed systems. So since a long time I'm working more or less on the server side. So I'm not the guy that's making buttons round or fancy or whatever. Everything I'm saying is more or less influenced by the customers I had. It's mostly consulting stuff. So it was long-running projects. It was mostly stuff with a bunch of, it's really loud, a bunch of consultants. And it's more or less legacy code I was working in. So who's working on a code base that's older than 5 years? 10 years? Automotive? Okay, 1. So the most thing is that on a core Java base you have to work over different versions over a long time. And since some time we have a faster change in our JDKs. It means we are going step by step back to the core JDK because a few things are not working from one to another thing. So mostly I'm working in this really old and legacy project. So if I'm saying something, have in mind I'm coming from this. So proxy deep dive. Mostly I start talking about proxies and then there is something I want to have. If you start reading this, it's more or less proxy is a very easy thing. Then you're starting with your design pattern book and saying, okay, this is a proxy. And then you start dealing a little bit more with these proxies, playing around and start learning. And then you have this feeling like, now I need more time. And this field of proxies is way wider than you're expecting. And you are reaching at one point this year, you're spending a lot of time and then there's way more to see. I want to have you on this journey today to my proxy deep dive. You don't have to stop breathing, this for sure. But the feeling in the beginning is more or less like this. There's a huge, big black hole. And what we want to do here. Okay. One thing, this guy is amazing. I think he can stop breathing for 5 minutes or 8 minutes or so. So proxies. Why I'm using proxies? Proxies can be used to extract generic parts. Sometimes these days people are using it, realizing this stuff with bytecode and bytecode manipulation. We are going only to core Java source code. So everything what we can do there. Proxies are possible to decouple parts, hiding technical stuff, several things. We have different kind of proxies. We want to have a look at it. But a proxy should be easy to use for the developer. So if you're using a proxy, you are happy if it is easy to use. It doesn't mean that it's easy to create. But let's say you have some class and you want to build a proxy. It would be nice to have something like a create builder or proxy or whatever method to say, this is my original, this is the task I want or the interface I want to go. And then you start adding functionality. For example, I want to add logging or metrics or maybe a security rule and the next security rule. if everything is done, you could say, okay, now my proxy is here. What would be the nice thing here? The nice thing here is that at several stages you can build your proxy instead of building everything at the same time. So decouple the time of defining a proxy and the functionality and the creation and activation of a proxy. This is something you should have in mind. If you're dealing with some other technologies, this would be nice if you could use it maybe like this. You say, give me something, but it should be a proxy, a virtual proxy with metrics. It's only an example. But it should be in a way that a developer don't have to think about how to build or how to create this proxy on a source code base. This is a target we want to reach, but how to do this? Difference between proxy and adapter. Sometimes people are mixing this up, so it's only to have it as a reminder. An adapter is called a wrapper, and a wrapper, I'm talking explicit here about an adapter with delegator. They're different on the field, but I'm using this one. An adapter is only the purpose of making things compatible to each other. A proxy is definitely not is not for this. So an adapter would be something like you have a legacy worker, some whatever implementation, and the next thing is you want to have an adapter. The adapter, what you can see is that the input you're using here, the adapter, the interface itself, you're defining something, yeah, and then the implementation itself. And what you have is here an array and here a list, for example. Both doesn't match, but you want to make it that both fits together. So this is an adapter. You're changing the signature and you're delegating to the original implementation. So this is what you're doing. So an adapter will have the logic of transformation. For example here, nothing fancy, but it's not a proxy, it's an adapter. So the next thing is how to use it. It's mostly easy. You say, I'm creating an adapter at some point, and then you're using your new method signature. Okay. The main thing here is you need to know the legacy worker, the legacy implementation itself. You need to know something about it. The next is you don't have inheritance between the old and the new thing. So it's completely decoupled. There's no inheritance. And it's mostly only for the transformation. Okay. Yeah, same creation time. Mostly it's implemented that the delegator and the adapter is created at the same time because there is no proxy inside. You can mix it up, we will see, but in the plain thing, it is at the same time. So, how to come from an adapter to a proxy? Proxy is, we need to know the legacy worker, yes. We want to proxy, wrap it somehow. And there is definitely inheritance between the proxy and thing that should be hidden inside. Okay, don't use it like an adapter, so a proxy is not changing the signatures. So please use with a proxy exactly the same signatures. Okay, how to do this? We have, for example, an interface, very useful, with a method work, input, output. And then I have an implementation. Again, very useful, only one single operation. If I want to build a proxy, what is a minimal proxy that fulfills all the rules we have is this here. We are implementing the same interface. We have something we are delegating through, and we are using exactly the same method signature and nothing else. This is a minimum proxy we can do and completely useless. It's okay. So we have different classes of proxies. One should be, for example, or one could be a security proxy. A security proxy is, again, you have this security proxy, you have something you want to delegate through, and now we want to change something from this proxy. The main thing is a security proxy has only the task to access if allowed, whatever this means. Here, it's a very easy implementation, and please don't use it in production. But you have the original one, you have something you will decide yes or no, and then you execute or you don't. So what's the challenge here? Well, If you don't execute, you have to think about what should be done if you have to deal with a return type, but more or less a main functionality of a security proxy is just execute yes, no, give an answer to this one. Remote proxy is another kind of proxy. This is mostly hiding technical details about communication. Again, we have this implementation. We want to execute now outside of the process something, and we have on the client side a remote proxy with the same method signature. I'm calling it exactly in the same way. And now we have to transform all this stuff out of the process, and we have this interface, something that is dealing with the technical details for the communication, and someone who's on the other side having the same interface and dealing with it. So this is more or less something you can use for remote communication. That's a task to fulfill. It is mostly technology-based work, so I'm not going here to implementation details, because if you want to go over network, a long-distance thing or whatever, you're choosing the technology for the communication you want to use. But the goal here is, again, the developer will see no difference between a local call and a remote call. That's a group of remote proxies. But now we are coming to a little bit more interesting proxies from my point of view. The virtual proxy. The virtual proxy is a bigger field. And now we are on the same machine. So let's assume we have this service proxy, this minimal proxy we defined in the beginning. And what should I change to have a virtual proxy? A virtual proxy has only one task: create something later. I want to decouple the point of creation, the place I want to connect through, and the heavy object that I have later, or I'm dealing with. And now we can think how would be the easiest and simplest solution. To fulfill this task, to create something later, I'm defining something. It's not created. And then the first thing is, if I have the first call on work, checking if it is null, I'm creating something. What I'm doing here is only, I try to minimize the initialization work for resources I don't need. This is an easy solution, and now we want to have a look what we can do here and what are the challenges. The main thing I don't like here is exactly this one. So, service is null. Why? Yes, not thread safe, no? Yeah, it's a more or less, you have no idea how many instances you will create if more than one thread is running. And the next thing is, I have the decision for fixed implementation. This is not nice, because if I want to switch implementations at runtime, this should be something more dynamic. And this one is not nice as well. Why? I force someone to use the default constructor to create something. Sometimes, if I have a heavy object, I need something to configure or to influence or to change the way how to create this instance. Even this I have to think about. I had to change. For example, we can do it with a proxy pattern or factory pattern here. Let's go in detail to this line here. The first thing, how to get rid of new, could be that I'm extracting it in a way that I will say, okay, now I have a service factory. The only task of the service factory will create my instance, nothing more. People start mixing it up with, okay, what's the right time to create it? No, it's not. It's only the way how to create the instance. Now I'm getting rid of this new. The next thing is how to decide what's the right time. For this, I will say, okay, this is a strategy I need. A strategy to decide now it's the right time to create this instance, but not with the knowledge how to create. If I'm dividing these two questions, what's the right time and what's the right way to create, I can play around with different implementations. Okay, another thread safe one. The new is only a delegator to the new constructor with a method reference. Okay. The next one could be what we had before, that I only check if this is null, create. It's the easiest way. This is the decision, and this is a way how to create. But both things are divided. I have a strategy, and I have a factory. How to use this? I would say my proxy will have the possibility to create an instance. It's only the description how to create. And I have a strategy to decide it's the right time to do it. And then, if there's an invocation of this method, I will go and say, lovely strategy, decide if it is the real time to do something, or it's the right time to do something. If yes, you have the way how to do it, do it. That's it. Now I've divided all this stuff. I have exactly the same implementation as I had before. But now I have the possibility to play with different strategies and different ways of creation. If I want to have the easiest or a synchronized version, the only thing I can reuse is a factory. I start reusing parts of my implementation. And the next thing is here, I'm only using here the keyword synchronized. But now I have two different behaviors. And I can choose what's the right one for me. But what happened if I want to have a method scoped? Method scoped would mean that every invocation of my method will create a new instance. Even this is easy to implement now. I'm using exactly the same factory. Okay. How to create. And the right time to create it is now for every invocation. That's it. I can start playing around with scopes. This is nothing different like a scope. Method scoped, whatever. I can create a singleton, I can create whatever the decision is. Okay. If I have a proxy, it's nice, but one proxy for one task. Now I start playing around with this. How to create this one. But the first question is, what is a useful combination of proxies? Here, security remote, virtual security, virtual security remote. In the end, they are doing more or less the same. But maybe we agree that a remote proxy that's going over virtual proxies, that's immediately creating an instance to check if it is allowed to do something, is not so useful. The same, creating an instance to go to a security check to see if it is right, yes or no, to execute something, and then going over the wire is not very efficient as well. So there must be a way to decide what combination of proxies are useful, yes or no. And the other way is how to create now a proxy that has to fulfill different tasks. Is first, I want to combine proxies. For example, I want to create a secure virtual proxy. That means, in the beginning, I start writing a virtual proxy. We had this one with a delegation of the real implementation. And as next, I start creating a secure virtual proxy. And this is using internally the virtual proxy. That's it. The only bad thing here is I can start creating complex proxies with this, but this is definitely hardwired. So you would agree if I would say this is not the way to go, because then for all combinations you have to create your special proxy in combination. So what could we change now to make this a little bit more comfortable? Okay. What we need is a generic proxy. And it's really, really long time ago. Whoever coded in JDK 1.3? Okay, then we both are the oldest in this room, I think. And there was one famous thing called dynamic proxy. Who using dynamic proxies? or heard about it? Okay, nearly the same. It's not bad. It's old, but not too bad. So now, what we have now? Until now, we saw proxies are a little bit more complex. So we started diving a little bit in, and we checked how we can write my own proxy. We divided the strategy how to create and the strategy what's the right time until now. We started combining proxies and identified not all combination of a proxy makes sense. The next thing is that we ended up in handwritten combination of proxies. And now we find this dynamic proxy. Then, yeah, we are lost in the dark. Let's see how to use this dynamic proxy. First of all, we need Java-lang reflect proxy. That's the first thing. The next thing we need is an interface or a bunch of interfaces. And after this, we need something we want to delegate through. Even this is the same. And then we are writing this one here. Everything clear? For sure. Well, yeah, we want to go there step by step. The first thing we want to cast to the interface that is the target interface we want to have. We start creating a new proxy instance. For this, we need a few things. First of all, for example, from this interface, we are grabbing the class loader. What is the source we are getting everything out of? Then there is an array. This array can be not only one interface, you can add as many interfaces you want to support as well. Now I know what's the target, I know what's the class loader to get everything from, and after this I need the way how to deal with the execution of a method itself. What I'm doing here is I have this invoke, I have the proxy, the reflection method, and the arguments. What I'm doing, I'm grabbing the reflection method, I will invoke it on this object with these arguments. I have everything together and can start invoking whatever method I want to invoke. How to make a virtual proxy out of this, because now I'm only delegating stuff. Having in mind what we have done, handwritten, the first thing is I want to check what is the implementation. It's not created until now. Okay. And then with the first invocation, I start creating this stuff. It's the easiest version. Okay. And if I'm checking this piece of code, it's a virtual proxy, not so fancy as the last one I showed, but here are a few things that are not generic enough, and I want to get rid of. The first one is I want to get rid of this definition, because I want to have it in a generic way, not only for my interface service. It means that I want to get rid here of the definition where this class loader is coming from, or explicit is service.class get class loader. And this one is hard-coded. All this stuff we can get from outside. Okay. The next thing is I want to get rid of this one. This is hard-coded in my proxy. And this we have to remove. And last but not least, I will get this instance from outside I want to delegate through. If I want to remove all this stuff and want to make it more generic, I can call this one a proxy generator. How it looks like? Yeah, that was this stuff with generics. I can say all the green things here. I will put it here, the proxy generator. I will make a proxy. I will have a subject and something to delegate through. I will create a new proxy instance. From the subject I will get the class loader. I have my array with exactly this interface, and I'm casting my last instance here. And then the same stuff here. It was exactly the subject get class loader, and the invocation. If I have this one a little bit more generic, then I reach some points. With the dynamic proxies, I'm definitely writing less code. Less code means I can define stuff, but there's runtime overhead called reflection. I can create every proxy I want with these dynamic proxies. But now I want to combine all these proxies in a little bit more generic way. So this is not solved until now. I have only the way how to create a proxy in a dynamic way. So if I want to combine all this stuff, I have to switch from a factory method, more or less, to a pattern we know, builder. With a builder pattern, I can deal with different steps. Let's see, first example, I want to cascade security proxies. So I have proxies of the same type, and now I want to chain them. I have different ways to deal with this. Two security, one virtual proxy. One solution could be one security proxy with two rules and a virtual proxy, and the next one could be two independent security proxies and one virtual proxy. The main thing, whatever I want to choose here, I need a generic way to cascade proxies. This is the main thing. You have two ways to chain proxies. The first one is that you start from the top and going to the bottom, or reverse from the bottom up to the top. Decide what's your way. And we now want to see how to build n security rules to one final security proxy. I have my security rule, for example, the decision it's allowed to execute yes or no, whatever is behind. And have in mind, this is a functional interface. Only as a reminder, we will use it later. Then I have a list of security rules somewhere. Okay. If I want to go top down or bottom up, it depends. You're saying reverse or not. And then for all these rules you have, you start building the final proxy. Going back, we learned how to build a generic proxy. I removed in gray all this stuff with get class loader and stuff. I only checking how to deal with this invocation handler. What I'm doing now here is I try to hold my last original here, my proxy builder original. And this is my last child I have to deal with. And the next thing is my invocation is working on exactly this child. And here I'm cascading this one because I'm setting now the last or the next level of my child. What I'm doing here is I'm only over holding instance, I'm cascading the invocation of proxies. Nothing more. How this will be used. If you have something like this, it would look like, for example, I have my demo interface, I have my create builder, my builder that I want to do, and I start adding different functionalities, for example, security rule 1, 2, and I'm done. This is only cascading proxies of the same type. What should we do if we don't have to deal the same type of proxies? If I want to cascade or build something that is not always the same interface, so more complex scenarios, I have to deal with different interfaces. What I can do now is that I will need or deal with something it's called nested builder. Example, not write a proxy, but the same stuff. I have an engine, a wheel, a car, and something that's using it. And mostly it ends up, for example, if you're generating with your IDE, fancy enough, a builder, then you have something like this. Creating a new builder with an engine, with a wheel list, and do something. Okay, so far. But how to come to this engine? This engine, what a surprise, is a builder. My new engine builder with A and B and C, and then I have a reference and I'm connecting both. And then this ugly thing here, this wheel list. Is this a good idea? I think in Italian has some 3-wheel cars, huh? But every wheel instance will be created, what a surprise, with a builder. If you have code like this and writing it in the right order, latest at this point you have to think about how to get rid of this boilerplate code. Let's see what we can do. If you have a challenge like this, the first step could be to make things done in the same way. One thing that's disturbing here is this list of wheels, because this is something that is done completely different. So I want to get rid of this. And the first thing I will introduce, what a surprise, a wheel list builder. Now I'm adding fluff. Okay, but why? Because now I can start searching for patterns that I can migrate together. Yeah, and the build method could be a little bit more interesting, but now I want to connect these two parts. The creation of every wheel together with a wheel list. How to combine this? One thing we can do is that I should think how I could switch between builders during the usage of a builder. So this I want to get rid of. And the next thing is, yeah, too many things. I played around with animations here. It's a disaster. So what I want to have is more or less an entry point, a wheel list builder. And there's one interesting thing here, because here at this point, at wheel, it's a method of the builder, so wheel list builder. I'm switching the builder. Now I'm a wheel builder with all the methods of how to create a wheel instead of a wheel list. And if I'm done with the definition of this element, I want to switch back to my original, my wheel list builder, because I don't want to have a bunch of useless methods. I want to reduce my autocompletion of my IDE only to the useful methods for the context I'm right now in. Okay, if I have done this one, I can start using this pattern to combine everything. So, how to do this, huh? Okay. The main thing here is that we have to think how to make this switch of builders in a generic way. The target should be something like this here. It should be something like, I have a car builder, I'm adding an engine with attributes, switching back, I'm adding wheels, I have my sub-builder, 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 and I'm done. This is definitely not nice. It's only to show different steps. Okay? How to do it with Core Java. If you're extracting this way of creating or nesting builders, you will see that the nested builder itself needs only two types, from the parent and from the child. The next thing is that you need reference between both. There's one way that makes it a little bit more convenient if you decide the parent will connect itself to the child. Here, this with parent builder. Parent is coming and connecting. If I have this, the next thing would be how to deal. The nested builder will have a method to finalize the building process to switch back. The next thing is, my parent will have a class, okay, and I have a naming convention. With this naming convention, you can do it in different ways. You can use an annotation as marker or whatever. But if I have a naming convention, I can say, okay, if I have a with and then a dedicated class name, for example, I have a pattern. What is a method to go back to invoke? What's here? I'm using the parent class, searching for the declared method with exactly this name I'm looking for, and I invoke all this. Okay, so with this, I have now the possibility to switch in a generic way using reflections. This is a way to connect itself with the parent. I'm connecting to my upper level. Okay, So it means the basic thing here is the parent builder will hold the child builder. Okay. The parent builder will have something like an addChild method to create this next level. And the child builder will extend the nested builder. And the nice thing, the most of this stuff can be generated. If you access to the class information itself, you can create nearly everything out of it. How it looks like if you would start doing it by hand. The first thing is, your builder would have here the builder of kit A and B. And the main thing is, I'm creating the builder and connecting with my parent. This is the first step we had. So this is done. Builders are connected. The next thing, I need a method to switch between builders. Here, add next level, add wheel, add engine, add whatever. And this is switching to the next level of builder. That's it. If I'm a nested builder, if I'm a child of this hierarchy, what should I do? I should only extend as this next builder or nested builder, and that's it. The rest is generic. The main thing is, I can do more or less everything with this. I can say I have different attributes, child 1, child 2, but you can be a parent and a child at the same time. It means you can start building trees. I'm a parent for my child, but I'm a child for my parent. That's it. It's exactly the same. Having this in mind, and thinking about this cascaded proxies, I'm now able to build complex proxies based on the level I'm right now. At this level, I could check if it makes sense now to add a virtual proxy or whatever. And if I need different methods to create this proxy, I'm switching context with every level. And in the end, I have my final proxy. Okay. One thing I really would recommend is that one functionality is one proxy. Build this in a robust way, and then later you can optimize. But we can do it a little bit more. Until now, we are switching only per instance. But have in mind, we could do something like this. You have a proxy, and this proxy has a decision if I want to use my origin or the adapter. If I want to use the original implementation, I'm invoking the delegator. If I want to decide for this method, I want to go to my adapter, I am invoking this one. What I have now is that I can switch on method level instead of instance level between implementations. Okay, there's another thing. So I can only override one method. How to identify a method is quite easy. In this here, let's assume we have a service with a method and an implementation. What I want to do is I want to identify a method inside a class. I am grabbing the method name and the params, the class. This is for me a key I'm using inside a store, a key value store. For example, hash map, you will see. That's it. This is my key to identify this key to this reflection method instance. How it looks like in code. The main thing is here, I have my invocation handler. I want to invoke something. I hold a map with key value pairs, a key to a method reference, or a reference to a reflection method. I have the original. I have something I want to delegate sometime through. And the main thing is, if I want to override or adapt one method, I'm adding an adapter, I'm grabbing the class, I'm going to all declared methods inside this class. I'm creating, for every method I have my identifier for my hash map. I'm putting into the hash map my key and my reflection method. The next thing is, later I want to invoke. If I'm invoking now, I can do exactly what I need. I have the method, I have the proxy. What I'm doing here is, I create this key based on the method. I check if I have a different implementation for this method, and if there's a different implementation, I will invoke this one, otherwise I will invoke the original one. Now I can switch on method level back and forward. This will give me quite a big flexibility what I can do with this. So, but this original implementation from Heinz has some challenges here. And what can we improve here? The main thing is if I have a service with a method, doWorkA, and I have an adapter with doWorkA method signature, this would match. If some of my colleagues is listening completely carefully and refactoring and will add an adapter with a method doWorkB, nothing happened, no? Because it's not matching. How to make sure that this is type safe so that you can deal later with refactorings and all that stuff. This is a thing we want to go. Okay, start with two methods. I have a service with a method A and B, and I have an implementation with A and B method. And now I want to start overwriting a few times. Having in mind that for every method I could create a functional interface like this. With a naming convention, I can create class plus method name, whatever, and this as a functional interface. This I can generate for every single method. And now how to combine it. The first thing is I'm doing exactly the same. I have my adapted methods, but now not only one adapter, I have a bunch of adapters. And if I'm adding an adapter, I'm going exactly the same way. Grabbing the class, every declared method, over all methods, creating a key, putting to the adapted methods and to the instance of adapters map. So now what I reach here is that for every method I can create an independent adapter. Every method is a functional interface, and I can start playing around with lambdas. If I'm invoking, it's more or less the same, creating the identifier. If I have something, an adapter, I'm grabbing this instance, invoking it, otherwise I'm using the original. I only extended it so that I can use a bunch of adapters, an adapter per method. So, what's good, what's bad? If I use this one without a builder, I have a challenge because here I'm losing the type safety because I can use useless stuff. Or I can add useless stuff. So what I need is, back to what we learned about the builder, I need with methods to create all this stuff. For example, for the first method, doWorkA, with doWorkA, and I'm using exactly the interface, the functional interface I created based on the original implementation. And this I'm doing for every method. And the good thing is here that I now start using it like the following. I can start, I have my adapter builder for this type. With the target I want to go through. With the original implementation I want to delegate. And then I can use lambda expressions for every single method if I want. How could I use this? Now what could I do with this? Having in mind you're playing around with mocks. Bytecode generation, dependencies and all that stuff. I'm creating now my builder. I have an interface I want to work with, but I have no implementation right now. But for this method, I want to have this reaction. Now I have my mock without all these dependencies. It's only a few lines of Java code. Okay. Everything must break if I'm switching method signatures. So it means that if I have two methods, I'm creating here this one as functional interface, and the target or the tool to go here is definitely annotation processing. Who used annotation processing once? It's not so bad. Try it. Because then you can start playing around. You're adding an annotation. For example, if you want to create something, it must only be available on source level. And then you're implementing corresponding to this annotation, an annotation processor that will generate all this stuff. The good thing is with every compile, everything is clear. If you're switching to something or you're refactoring something, a compile will break. Functional interface for the adapter is easy to use, and the whole adapter can be, everything could be generated. That's quite easy. Until now, this implementation is based on dynamic proxies. This will lead to latency. if you want to have it a little bit faster, we can do everything now in a static context. Because if I have an interface with two methods, what can I do? I can generate this one. Sure, again, as function interface is exactly the same stuff. The only thing is that I'm now getting rid of this dynamic proxy and this reflection access. So I say my static object adapter will have the service itself, will have an adapter for every method I want to deal with. And if there's a method, I'm only checking if it is not null, A or B. And the good thing again, 100% can be generated. If you're generating code at this level, have in mind that you have to deal later with this information. For example, to generate stuff, you can say add static object adapter or whatever. And everything that's generated, not only add with generated, but please give some more information. It's an object adapter or it's a proxy, it's whatever, so that you can deal with different things. Everything now is done until the compile process. But sometimes we have now different versions. Now we are going a little bit deeper with these proxies. I want to do all this stuff at runtime. Now we have a huge break. There is this time until Java 8, and then there is this time after Java 8. Who's dealing with JDKs after Java 8? Okay, for you, I have a hint where you can read what to do with this. And for all the others, here is the solution for the JDK 8 version. This is based on the newsletter from Heinz Kabutz. And the question is, I have to solve how to compile in memory. And the next thing is how to activate or how to get the right class loader. We have the solution now for up to JDK 8. What you need is a Java compiler, and until Java 8 it's in tools.jar. We need a holder for the source code we are generating. The next thing is you have to come to this, that you need this simple Java file object. There is not so much information in the web. You have to really search a little bit for this. But if you are able to find the simple Java file object, you will find some examples how to hold source. The source will be here inside the jar sequence, and this is a generated source code. And this is kind of source. So if you have this, you are able to hold generated source code at runtime. How to compile in memory. You can do this. You need a holder for the bytecode. And the holder for the bytecode is again a simple Java file object, but this time it's kind of class. So this is an interesting thing. And we don't want to have round trips on hard disk, so we have a byte array output stream. So we are holding everything in memory, the generated bytecode. The compiling process itself, it's, well, read it if you need it. But the main thing is that you have to combine now the source code and the bytecode, and this could be done in this forwarding Java file manager. And this will force the Java compiler to write immediately in my in-memory holder instead of round trip over the hard disk. And then we have this generated class file. I'm not expecting that you understand the whole stuff right now. I only want to show here is a point. Slides you can read later, and then you can try all this stuff by yourself. The compile itself is quite easy. You need the generated Java source file with a class name Java source. You're grabbing the diagnostic collector and so on and so on. Then the Java compiler. If you have the Java compiler, then you start combining both. And latest, if you have everything together, you will start compiling. This is the final thing, task.call. Magic. But now I have from something I want to analyze generated source code. From the generated source code, I'm able to create this bytecode. What should I do now? What's the right class loader? Right now we are talking about up to Java 8. Here it's more or less you have unsafe defined class. We are not using it. Who's using unsafe? Oh, good. Never do it. Never. And then proxy defined class 0. but here you have to make sure that you are grabbing the right method for the right JVM, and this is only valid up to Java 8. But the nice solution here is, at runtime you can decide what kind of proxy you need. You can generate it, you can compile it, and you can do everything without a round trip on the hard disk. This is really, really, really fast. For you guys here in front of, you don't deal with this legacy stuff like Java 8. You have to read this one. This is very good stuff from Raphael. He's creator of this ByteBuddy stuff, and he wrote how to replace this unsafe with the new thing. Okay, so we heard a lot. What happened? We started with what is an adapter and a proxy. We saw that the proxy will not change the signature. We started handwriting this stuff with one single thing. We have secured proxy only to make sure, invocation, yes, no. We have a remote proxy to hide technical stuff, and we have this virtual proxy. Virtual proxies only have the task to make things later to decouple lifecycle. Okay. If you have this one, you can decide what's the right strategy to decide and what's the right time. To create an instance and what's the right strategy to do this. If you're dividing these both things, you have the flexibility to create with a few lines of code different scopes, method scopes, singleton, whatever you want to create. If this is handwritten, you have to write a lot of stuff. You can use the dynamic proxy that is available since JDK 1.3 and write all this stuff in a generic way. The overhead you have is dealing with reflection. One thing, if you want to build a complex proxy, don't build one handwritten proxy that's doing everything. You can do it on a source code level, but the permutation of all combinations will be huge. So think how you could combine all this stuff in a generic way. I showed you the way of a builder and the nested builder, how to switch between dedicated special builders. If you have this, you have a good tool to make complex proxies, but in a way that your IDE will help you to provide only methods that you need. If you don't want to switch whole implementations, but you want to switch only on a method level, you can use this dynamic object adapters. This can be realized with a dynamic proxy as well as with a generated one or handwritten one if you don't want to deal with reflection overhead. Altogether, you have now the possibility to switch whatever you want. You can use it like a mock. You can add cross-functionality. You can use annotation processing to avoid writing all this stuff by hand. And if this is not fast enough, a static dynamic object or static object adapter, you have an idea what you can do to generate at runtime, compile, and push it to the class loader. Have in mind, this last thing is dependent on the JDK you are using, not only the version, the vendor itself as well. If you want to see some playground, you can use a proxy builder. There are some of these ideas already implemented, and it's far away from production readiness, so please don't grab it, use it, and don't think about it. Okay, but if you have ideas, let me know. If you want to improve, make a merge request, call me, and the easiest way to catch me is via Twitter at Sven Ruppert. And if you have some questions, comments, whatever, feel free. I'm here because I'm hungry. I have to leave now. And everything together, I would say. Thank you very much for your time.